So our first method here is factoring. So we're not just factoring a trinomial now, we're setting our trinomial equal to 0 in order to solve for the x-intercept. So we've got a lot of practice with factoring now. We spent a couple weeks on it. If it's still not your favorite, we're going to have a lot more practice. So here we go. So we're going to identify what we can do here. First step in factoring is solving for a GCF, which we don't have. We set the equation equal to 0, so we move everything over to the same side. This is number 1 on your guided note sheet. Solve by factoring. It's in the upper left. So I'm going to factor this trinomial into what two numbers multiply to negative 30 but add to negative 13. And that's negative 15 and positive 2. 2 times negative 15 is negative 30. 2 plus negative 15 is negative 13. And so I'm going to set this equal to 0. And now, in order to solve for this, I know that this can be equal to 0, so y plus 2 equals 0, because if this binomial equals 0, then whatever this is, the whole thing is going to be equal to 0, because 0 times anything is 0. So I can set this binomial equal to 0, and I can set this binomial equal to 0. Y minus 15 equals 0. So now I can solve for both. Y equals negative 2 here, because I subtract 2 from both sides, and y equals positive 15 here. So those are my two answers. And if you want to write this in roster notation for practice, we can write it as y equals negative 2, comma 15. Okay, so we're going to move on to a little bit more of a challenge because we've got our c term over on the other side. So we must make this equal to 0. So we must make the whole equation equal to 0. So I have to move everything over, all my terms, all my constants, to one side. So I subtract by 80. It's my first step. And then I can go through and factor. So again, first step of factoring always is to look for a greatest common factor. So 2 goes into all of these terms. So I can simplify as 2 times x squared plus 3x minus 40. And now I can solve it I can solve for my trinomial, because a is equal to 1 here. I can say what two numbers multiply negative 40 but add to positive 3, and that's going to be positive 8 and negative 5. Again, to solve this trinomial, because it's equal to 0, this 2 term doesn't matter because I don't have a variable associated with it. So it does matter, but in solving this equation, it's not going to have an impact on the roots. So I set this binomial equal to 0, x plus 8 equals 0, and I set this binomial equal to 0, x minus 5 equals 0. So if either of these becomes 0, the whole equation will be satisfied. So x equals minus 8, x equals plus 5. So if writing that in not roster notation, x equals negative 8, comma 5. All right, number 3 is a different example. So if I look at number 3, I can, first step, must move everything over to one side, set it equal to 0. So I'm going to add 10w to both sides. And I get 4w squared plus 10w equals 0. Now, again, look for a GCF. So 2w goes into both of these, and I'm left with, that should be 2w plus 5. 2w times 2w is 4w squared, 2w times 5 is 10w. And now I can set both of these equal to 0. This monomial equal to 0, so 2w equals 0, and this binomial equal to 0, 2w plus 5 equals 0. And I have to do this one as well because I have a variable associated with that. I can't just forget about that constant out in front like I did in the last one. So divide both of these by 2, so w can equal 0 here. That would satisfy the equation. Or subtract 5 and divide by 2, so I get w equals negative 5 over 2 here. So I can rewrite this in roster form. W equals negative 5 halves, comma 0. All right, and our last example of factoring, just get this up here, and then number 4. So in number 4, I can either move this negative 5 over to the right, or I can move the 4 and the p over to the left by subtracting both of them, which is what I decided to do here. So decided to move both of those over. I rewrote it as 5p squared minus p minus 4 is equal to 0. So that's my first step, taken care of. And now this is a specific case because a does not equal 1 here. So this is my a does not equal 1 factoring case. So what I have to do is multiply a times c, so 5 times negative 4, and then rewrite my new trinomial. So when I do 5 times negative 4, I get negative 20. So I rewrite this as p squared, so that's that same first term without the 5 associated with it, p squared minus p minus 20 equals 0. And now I can factor this new trinomial. What two numbers multiply to negative 20 but add to negative 1? Remember, when I don't have a number written out here, it's just assuming that there's a 1 there. And so negative 5 times positive 4 equals negative 20. Negative 5 plus 4 equals negative 1. And then my last step in factoring, or my last two steps in factoring this trinomial when a does not equal 1, is I have to bring my negative 5, or my 5 back in here. It's positive in this case. Bring my 5 back in here and divide whatever I got for these two terms by that coefficient. And then I reduce my fractions. 4/5 is reduced, so I'm going to bring that 5 out as my new coefficient as 5p plus 4. And then 5 divided by 5 is 1. So my new binomials here are p minus 1 and 5p plus 4 equals 0. So now I set them both equal to 0. P minus 1 equals 0. 5p plus 4 equals 0. And I get p equals negative 4 over 5 and positive 1. That should be a squiggly. Okay, so the next way that we're going to solve these quadratics is by taking the square roots. And this is very handy when you have something being squared or a variable being squared and a number. If those are the two things that you are considering. So in all of these, I have a variable being squared, and the other term here is just a number. So even here, where there's 3 terms, I can combine 10 and 1 and make that a number, and 11 and 59. I can set a variable that's being squared across from a number. And what I mean by taking square roots is that when I add 81 to both sides, I can do 16d squared equals 81, divide by 16, divide by 16, I get d squared equals 81 over 16, and then I can take the square root of both sides because I have a variable being raised to a second power across from a number here. So then I get d equals plus or minus 9 over 4 in this case. The square root of 81 is plus or minus 9. The square root of 16 is plus or minus 4. So in 6, I can do the same thing, isolate the variable, and what I mean by that is isolate this m squared term. So I divide both sides by negative 6, and I get m squared equals minus 8. So now I'm going to take the square root of both sides, and I get m equals plus or minus I radical 8, which I can simplify into radical 4 times 2. So this becomes m equals 2 plus or minus 2I radical 2. Seven, again, I'm working to isolate this x squared. So the first step will be to subtract 11 from both sides. So then I have 3/2 x squared equals 48. And now I can multiply by 2 over 3, which is the same thing as dividing by 3/2. So that cancels with that, that cancels with that. Multiply 48 by 2 over 3, and I get x squared equals 32. Take the square root of both sides. I get x equals plus or minus the square root of 32, which I can ultimately break apart into square root of 16 times the square root of 2. So x equals plus or minus 4 radical 2. In number 8, again, I'm trying to isolate my variable that's being raised to the second power, so I'm going to subtract 10 from both sides. So I get negative 7s squared equals minus 9, divide by negative 7 here, and I'm going to get s squared equals 9 over 7. Take the square root of both sides here, and then this is where your practice with radicals is going to come into play. So I get s equals plus or minus 3 over the square root of 7. So the square root of 9 is 3, square root of 7 is square root of 7. But most of you will recognize you can't have a radical in the denominator, so I have to multiply it by the radical over the radical. So ultimately I'll get s equals plus or minus 3 radical 7 over 7, which is radical 7 times radical 7. And those are two of the first ways that we can solve. So we just solved by factoring, and we solved by taking the square roots of both sides. In the next video, we'll solve by completing the square and by using the quadratic formula.
Time to make some food.
I am still recording.